Radio the co-host. So it
Host disabled participant screen sharing. That's what it says.
try again. Try again. Now I've made you the co-host.
Yeah, correct. I think now it's opening up. It's not opening. Doctor, otherwise shall I? One second.
So you've logged in from 2 screens.
Oh, is it? It's only one, no, doctor. Can you see my screen, doctor?
No, sir.
It's not opening up. Is it possible? Can you put the slides, ma'am? Shall I send the slides to you?
Mail it to me at sonalsaxena3@gmail.com, sir. I'll put it up.
Yeah, correct. 1 minute. No? I've sent, doctor.
Yeah. Huh? I've got your mail, sir. I'm just putting it up.
Yeah, sure, please.
Okay. Is my screen visible now?
Yeah, it's visible.
All right, sir. All right,
Sure.
sir. I will just begin.
Yep.
So, thank you, Balaji sir, for joining this PG Masterclass, and I welcome all the postgraduates who have joined us today for this interesting and very good. I mean, not only from an exam point of view, but also from a reporting point of view. I don't think Balaji sir needs any introduction. He's at CMC Vellore, as we all know, and he takes care of the ICWAS for the South region. He was also the editor of IJMM for quite some time. So over to you, sir. We'll not waste any time and let's begin.
Sure. Thank you, Dr. Sonam, for giving an opportunity to talk about the topic which is quite familiar to me and which I am continuing to pursue with the passion for quite some time. Actually, I should apologize to Dr. Sonam for quite few times, though she was insisting for the past 1 year, somehow I was not able to meet the time date. Even this time, I refused. I said I will postpone to January. For the simple reason, in UCAST and CLSI, they may come with the updates in Jan. So that's the reason I was thinking in Jan. Then later I realized that even if they release in Jan, to understand and to implement, it may be a little later, February or March. So I don't mind taking the updates next time, because this is the bread and
We'll
butter.
schedule it in April, sir.
Sure.
The update.
This is the bread and butter for every diagnostic microbiologist, which is very important for ID physicians to choose appropriate antibiotic dosage duration. So since this is a very important topic, and especially quality control of antimicrobial susceptibility testing is every day's microbiologist work. So what I'm going to talk for the next few minutes is, can you move on the slide, ma'am, please? Okay. So for the next few minutes, I'm going to talk about the importance of reliable susceptibility testing. Then I will just recall few important steps of do's and don'ts in disk diffusion antimicrobial susceptibility testing. That's going to be more of a recall. Then quickly I will move to the MIC testing. I'm not going to talk about the broth microdilution, which many of you will be familiar, and it's something similar to DD. Today, I thought I will spend quite some time for the e-test and commercial antimicrobial susceptibility testing, like Phoenix, automated from bioMérieux, BD, and many other companies. So it's the commercial automated system and e-test, which I will be talking a little more. Then briefly, I will mention about the CLSI UCAS difference. So you should not have confusion which one to follow. Then the major important portion of today's talk will be centered around the quality assurance, internal verification, that is QC testing scheme and QC strains, and little more on verification and validation of commercial and automated susceptibility systems. Because now in the EQUAS, we see of the 1,000 plus participants, close to 40 to 45% of the participants are using or commercial automated systems, susceptibility testing system. So I felt that it's imperative to cover that as equal to the manual methods. Next slide, please. Okay, importance of reliable susceptibility testing. Just quickly to recall, main foremost, very, very important is to give guide the right therapy for a patient, infected patient, with identification of the organism and appropriate drug. Because that's more important. In one of the most important in antimicrobial stewardship is the appropriate drug. Then comes the dosage, duration, de-escalation, and other things. So the drug is the most important, appropriate drug is the most important. Then you need to, based on the cumulative antibiogram, which you develop in the microbiology lab, will help to formulate the empirical therapy for the hospital to that given location, region, or even for the nation. That's two. Third one, surveillance of AMR. We continue to look out for any emergence resistant for any drugs or for bugs, drug bug combinations. And as well, this will help you to spot out any epidemic, endemic, or outbreak occurring within the continued monitoring system. So this is about the reliable susceptibility testing benefits. Now, I will briefly go through the do's and don'ts of disk diffusion testing. You all know that Muller-Hinton agar is the standard agar which we need to use for the disk diffusion testing. And the medium should not have more than 4 millimeter thickness, and it should have pH of 7.2 to 7.4. So this is very important. Muller-Hinton agar 4 millimeter thickness and pH of 7.2 to 7.4. It should be, the agar plate should be stored at good temperature, storage temperature of preferably 4, even minus 20 is fine. The antibiotics disc should be definitely stored in minus 20 minimum. Inoculum should use McFarlane 0.5, which is approximately 10 to the power of 8 bacteria colony forming units per ml. And the incubation for a disk diffusion test is 35 degrees centigrade. And the atmosphere should be ambient air. Next slide, please. Okay, inoculum preparation. This is the most important step where the human skill comes in. If you don't prepare inoculum, this is the human error. So you need to be a little careful with experience and with the utmost attention that needs to be done. Generally, the recommendation is not to restrict yourself to 1 or 2 colonies. Try to pick up several morphologically similar colonies. Here, it's very important is morphologically similar colonies you need to pick up. Otherwise, sometimes you land up in picking up atypical variants. Once you pick up the colony, then you need to emulsify or prepare a broth by incubating for a short duration of 30 minutes. Then prepare the McFarlane match of 0.5, and this McFarlane tube can be maximum stored for 6 months. Again, you need to prepare the McFarlane tube. So forever you cannot use the McFarlane tube. So this 0.5 is for all the gram positives and gram negatives. The only exception is for Streptococcus pneumoniae. For blood agar plate, you can use the same McFarlane 0.5. Whereas for chocolate agar plate alone, you have to use McFarlane 1. The only exception is Streptococcus pneumoniae. Then if you are preparing the McFarlane's tube yourself in-house, you need to be a little watchful that there is a variability expected with the types of glass material you use to prepare. So that's where it's a little tricky. If you are not sure about the glass material, it's better to go for a commercial purchase. And nowadays, you don't need to prepare the McFarlane's match. It's rather easy to buy an electronic gadgets, that is photometric device, or it's called density check. There are more in the market. Any one company you can choose, which gives an accurate opacity. Next slide, please. Okay. Inoculum preparation, it's very important. As I mentioned to you earlier, pick up more number of colonies, several similar morphological colonies, then inoculate in a 1 or 2 ml broth, incubate if required, vertex it, then look for the McFarlane match of 0.5 through some electronic gadgets. And if you want, you can do this black dotted line chart comparison also with the 0.5. The only exception, as I mentioned to you, it's for Streptococcus pneumoniae. It's fastidious organism. The another recommendation is directly you can pick up the colony and streak onto the plate. If you are not doing that, then for chocolate agar alone, you can do the McFarlane 1. Next slide, please. So inoculation of the agar plates. Most important is once the inoculum is ready, now you have to pick up the plate. In the plate, the most important is there should not be any water droplets within the plate. Make sure that the plate is dry. And if you want to dry little early, because it takes time. Sometimes the plate takes 15-20 minutes to dry, or even 1 hour to dry. Usually it takes 35-40 minutes to dry. So what we do is majority of the time we put the plates in the biosafety cabinet to enhance or speed up the drying condition of the plate. So if you put over the this buttoned sheet of the biosafety cabinet, you need to be little careful. Because if the biosafety cabinet is not calibrated and the HEPA filters are not changed and it's not calibrated, then you may tend to get contamination from this machine into the plate. So if you are not sure about the biosafety cabinets, it's better not to use that cabinet for drying the plates. Even incubator, if you are keeping it in the incubator should be thoroughly cleaned, and then you can use that incubator for drying the plate. So after drying the plate, take the inoculum and streak onto the plate. Next slide, please. So application of the antibiotic. Once you streak the plates with the inoculum, then you need to choose the antibiotic. And you know that various antibiotic discs are commercially available, or you can prepare in-house. And the strength of the disc, it's very important, and it should be appropriately added on to the disc. And you should be a little aware that UCAS disc concentration varies from the CLSI disc. Not for all the antibiotic discs. Certain antibiotic disc concentration varies from CLSI to UCAST. When the concentration varies, the interpretation zone of inhibition also varies. So that needs to be kept in the mind. Otherwise, by and large, majority of the procedure is almost the same for CLSI and UCAST. It's the disc and its interpretation. These are all the two important things which varies between CLSI and UCAST. Then you incubate the plate into the incubator. Appropriate incubation, CO2 incubation, or non-fastidious requires CO2 incubation. Non-fastidious doesn't require CO2 incubation. And after appropriate incubation overnight, next day morning, you can take the reading. Next slide, please. Okay. So to simplify what I have told you earlier, it's called as 15 minute rule. Use the inoculum after inoculating onto the plate, the organism, within 15 minutes, you should see once you have prepared the inoculum in the tube, McFarland to plating, within 15 minutes it has to be done. Because in our lab, in many of the labs, tertiary care centers, they will be doing hundreds of plates simultaneously. When they do hundreds in our department, we do 400 every day. So if you are doing batch wise, sometimes it may take more than 15-20 minutes after preparing the inoculum to plate. So it's very important, within 15 minutes of preparing the inoculatum, you have to put that on the plate. And once it's inoculated, the organism is inoculated onto the plate, within 15 minutes, the disc has to be placed. And within 15 minutes of placing the disc on the plate, antibiotic disc on the plate, you should start the incubation, or it has to be placed in the incubator. So it's very important. Next, how do AST plates look like? So ideally, it should look like this, where it's a confluent growth on the plate should be seen. Whereas how it should not be look is, next press. You can see here it's not confluent. You can see patch rings. This is done in the rotator. So you can see the concentric legs. This is by hand. You can see lot of in-between patches, uninoculated areas. It should not be like that. So it should be a confluent thin growth. It should not be a thick growth. It's very important. Next, the agar depth, how it influences the result is, if it is too thin, then what will happen is, it will show the zone of inhibition. If it is thick, you can see the QC range for Pseudomonas aeruginosa for ceftazidime. If it is 22 to 29, if you pour 28 ml, this 28 ml in a standard plate will give you 4.2 millimeter thickness. For that, the 23, which falls within the QC range. So if it is 28 ml, 30 ml per the plate, it works well. If the ml is less, 22 ml or 25 ml, what happens is, the thickness is less, hence you will get false susceptible. And the QC range also, it won't be there. So that's the importance. And reading the zones. This is very important. If you all know that for Proteus, you have to ignore the swarming. For Streptococcus, you have to ignore the hemolysis. For Trimethoprim, there will be 2 zones of inhibition. the AC zone or 20% margin has to be discarded, or you should disregard that one and take the reading. And this is for the Proteus streptococcus and for any organism for the cotrimoxazole. When it comes to gram-positive, Staphylococcus and Enterococcus, for linezolid and vancomycin interpretation, you should use the transmitted light, plate held up to the light. And for Enterobacteriaceae, always this ampicillin will have some pinpoint colony in the zone of inhibition. You can, this fine growth, sometimes you can ignore this fine growth. Okay, next. So now these are all the most familiar things which you know I have tried to recall. Now we'll move to the minimum inhibitory concentration. In the minimum inhibitory concentration, I'm not discussing about the broth microdilution. Rather, I'm focusing on E-test and commercial automated antimicrobial susceptibility testing. So why minimum inhibitory concentration is important these days is you can look at the difference between the DD and MIC. The MIC is quantitative, whereas DD is qualitative, where you will say susceptible, intermediate, resistant, whereas MIC exact measure you will know. This is useful for essential agreement. This is for the categorical agreement. MIC is more accurate, whereas DD is not accurate. If the susceptibility is in the borderline susceptible, result should be confirmed with MIC. Because in MIC, when you test, one tube dilution difference is acceptable. If one tube dilution difference is acceptable, means that corresponds to 3 millimeter zone of inhibition. So when there is a borderline susceptibility, to confirm whether that is correct or not, you need to do the MIC. That's the problem with the DD. And the dosing and duration for the patient can be decided based on the MIC, but that cannot be done with the DD. This is the most important point you should remember. With the disc diffusion, the dose and duration, that is the antimicrobial stewardship, cannot be implemented or executed with the DD. That's why it's important to have an MIC that will guide you for appropriate dosage and duration. The drug can be decided with either of one, DD or MIC, but dosing duration only with the MIC. And this will be more influenced with the multiple component of the test, that is medium, inoculum, incubation by the DD, but much will not be affected by the MIC. Next slide, please. Okay. So now in most of the places, very frequently these days, they use E-test because newer antibiotics, most of the newer antibiotics which have been cleared by FDA in the recent past, last 1 year, which are not yet available in India, but certain drugs are available in India, like ceftazidime, Bactam, where E-test strips are readily available, but in the automated system, it has not been incorporated. So slowly they are coming, and a few companies have already incorporated into the automated system. So when you are doing E-test, how to quality control the E-test? So this is where I have plotted a diagram. You can see the E-test can be validated using the broth microdilution. So you set up a broth microdilution with the same MIC breakpoints, 0.015, 0.3, 0.6, 0.6, 125 like that. And similarly, you will see the same corresponding values in the E-test. Then at least 10 or 15 isolates can be tested by both BMD and E-test and plot the results likewise, what I have shown in this diagram. So if there is an agreement between E-test and BMD, then those agreements points are all green in color. The one which are not in agreement, that is BMD, MIC value is 0.03, it's here. Whereas in the E-test, same isolates, it is 0.06. I put it here. So how you interpret this is, if it is identical, then it's absolutely no issues. If there is one tube dilution difference between BMD and the E-test, it's acceptable. One dilution lower or one dilution higher, it's acceptable. So these three rows are acceptable. Anything two dilution higher or two dilution or more than two dilution, it's not acceptable. And similarly, two dilutions or more than two dilutions lower is not acceptable. So this is how you QC the e-test. Because you are getting the e-test, you are not sure whether the e-test has been quality controlled or not. So to check the quality control of the e-test, you need to do this comparison with the BMD, at least with a few isolates, and match and take a reading like that. So if it is more than 2 dilution lower or higher is not acceptable, might lead to either false susceptible or false resistant results. Okay, next slide, please. Okay, there are many people I have seen the people taking interpretation not the way it has to be done. So here for them to recall, this is mainly problem with the combination drugs, not with the single drug. Single drug, you know the MIC value, you give the MIC value. Whereas when it is a combined, like ampicillin sulbactam or cotrimoxazole, that is sulfamethoxazole and trimethoprim, then they don't know how to interpret it. See, for MIC of ampicillin and sulbactam is 2:1 ratio. So it has to be, reading has to be taken as 8/4. If it is cotrimoxazole, it is not 2:1 ratio, it is 1:19 ratio. So if the MIC of the trimethoprim is 2, then you have to multiply into 19. Then you have to put it as 2/38 microgram per ml. This is how the interpretation has to be done for the e-test if it is a ratio based. If it is a fixed beta-lactamase inhibitor are fixed, then there is no issue. So because it's a fixed, all are 4 microgram per ml, either tazobactam or avibactam. So ceftazidime avibactam or piperacillin tazobactam, it's all 4 fixed. Then it's straightforward. You won't make mistake. So that's how the e-test needs to be interpreted. Next slide. Okay. So now we come to the e-test is over. Now we move to the commercial AST system like Phoenix BD or Biomerio Vitec or something like that. Limited concepts. There are differences are there. If you do manually, what are the advantage and disadvantage? If you do commercially AST automated system, what are the difference? So the microscan and Phoenix works with the principle of broth microdilution, which is a reference standard, gold standard. Whereas Vitec 2 operates on the growth curve algorithm, slightly different, which is not on a reference standard, but it gives equivalent result. And this can be interpreted with susceptible, intermediate, and resistant. And this assesses the categorical agreement, not the essential agreement. And this interpretation depends on the breakpoint and the expert rule developed by the device. Whereas when it is manually done, we can use the sensititer or e-test, where you have the materials and you can do. And it expresses the exact MIC, not the truncated MIC here. Here it is the exact MIC can be done. And in addition to the categorical agreement, you can get the essential agreement also. And this is independent of breakpoint and expert rule. Next slide, please. Okay. Now, you need to be little careful with the commercial automated AST system, because now you need to understand with certain antibiotics what kind of trouble you will expect. So if the breakpoints are too close, that is, it may give some error in the machine. For example, enterobacterials and ciprofloxacin, the MIC breakpoints are very close. Look at the susceptibility. It is 0.5 microgram per ml. Resistant is 1 microgram. So there is no only one dilution, or it's very narrow. So it's going to be a little difficult. So this happens with the ciprofloxacin, enterobacterials, and most of the tetracycline groups, tigecycline, tetracycline, minocycline, will have this problem because their MIC will be very narrow. And again, for Staph aureus, vancomycin, it will be very narrow. Anything less than 2 is susceptible, more than 2 is resistant. So again, you need to be a little careful when you are taking reading for this kind of bug drug combinations. This affects the essential agreement plus or minus 1 log dilution. But categorical agreement, majority of the time, there won't be any issue. And if it is two separate, long, wide range of concentration is needed in the panel, because they will usually have a truncated panel of only 4 dilutions, one above the resistant, one below the susceptible. So wide range of concentration is needed in the panel. The example is Astronum and Pseudomonas aeruginosa. Susceptible is anything less than 1. Resistant is anything more than 16. Next slide. So you can't say all the time the automation is all advantage, all good. Definitely it's good, highly standardized, very useful. But there are few disadvantages are there, which you need to be little careful and look out for. As long as if you are aware, I think majority of the time there won't be any problem. In most of the time in automation, what happens is in the panel, there are many antibiotics are there. Tetracyclines, macrolides, beta-lactams, beta-lactam inhibitors. So you can't be guaranteed that all the antibiotic present in the panel will have full potency. By chance, certain antibiotics inherently have problem that they may not have the potency retained for longer duration, similar to macrolides or tetracycline, especially the carbapenems and beta-lactamase inhibitors. Sometimes they may lose potency, it may give error. So that's why I would like to highlight within the panel, certain antibiotics are very strong and it will retain the potency irrespective of the storage. But these are all the drugs which will lose or decay, antibiotic decay will happen with this carbapenem, beta-lactamase inhibitor. This will lead to major discrepancy, that is false resistance. If incomplete truncated diluted series, only 4 are there, then the breakpoint which divides the wild type distribution may not be made out. And if it is too narrow, no intermediate categories there, then it's okay. Too close and too wide, which I explained to you in the last slide. So these are all the little difficulty with the automation system. Next slide, please. Okay, now I come to another important area, how to differentiate what is the difference between the CLSI breakpoint and UCAS breakpoint, how it is decided. See, the CLSI, they give heavy importance to MIC distribution, MIC 50, MIC 90, and how the MIC correlates with the clinical outcome. So that's what the CLSI does. Whereas in UCAST, multiple steps, they go ahead and they not only link the MIC distribution and the clinical outcome, they also consider the important middle point, that is pharmacokinetic and pharmacodynamics. So this is the major difference between CLSI and UCAST. They give heavy weightage to PKPD. So why this PKPD is very important is these days, because now it is an antimicrobial resistant era. Antimicrobial stewardship is insisted in every place. For antimicrobial stewardship, it's not only the appropriate drug, it's the dosage and duration. And the dosage and duration may vary from system to system. In the respiratory system, one drug will work well, and another drug will work in the urinary system very well compared to the respiratory system. So if you know the PKPD of the drug-bug combination in each different system, then it becomes much easier to tailor, customize the therapy for the individual. That's why the PKPD is given heavy weightage by the UCAST. Slowly, the CLSI also is catching up with the PKPD. Because the PKPD, they give heavy weightage, the probability of target attainment mean values with the confidence interval of 95% to 99% is the cutoff set by UCAST, whereas the CLSI, the confidence interval of probability of target attainment is only 90%. Since there is a difference in the percentage of probability of target attainment, the MIC value breakpoints also differs between the UCAST and the CLSI. Now I will show you summarize the breakpoint of CLSI and UCAST to you in the next slide. Okay. Can you press the next two buttons also, ma'am? Okay. The susceptibility breakpoint is almost the same between the CLSI and UCAST. The difference between the CLSI and UCAST, will come only in the resistant breakpoints for every drug and bug combination. In very few only the difference between the susceptibility breakpoints are there between CLSI and UCAST. So it doesn't matter. As long as if it is not susceptible, you can ignore that one. Only resistant, the problem comes. In CLSI, they give the intermediate and wider buffer zone is there. The technical error also can be taken care. Whereas in the UCAST, it will not be taken care. So it is quite strict. And then see, generally, CLSI breakpoints are quite liberal. So one tube dilution higher they would have kept. Whereas in the UCAST, one tube lower it will be there. That is the difference between the CLSI and UCAST. As I mentioned to you, the UCAST has raised the bar for probability of target attainment to 95 to 99. Hence, the susceptibility breakpoint, one tube dilution lower it will be there for UCAST, and one tube higher it will be there for CLSI. That is the major difference in 99% of the drug bug combination. The only exception where the UCAST differs from CLSI from this general rule is carbapenem. In CLSI alone, the carbapenem susceptibility will be one tube dilution lower than UCAST. In rest of the things, it will be higher. So this is basically due to the probability of target attainment. And I can say easily that UCAST is more strict, whereas CLSI is quite liberal. But still, it won't affect much of the treatment outcome. But the advantage of UCAST is the early emergence of the resistance can be picked up and avoided. Okay, next slide. Quality assurance and internal verification. So now we discussed about the interpretation and whatever we need to give appropriately for the physician. Now we will come back to sustaining the quality in the lab, in the susceptibility testing, and especially for automated system. So where error can occur in the susceptibility testing is, one is in the medium, second, size of the inoculum, antimicrobial disk potency and its storage, incubation time. Then in commercial automated system, the equipment go wrong, and sometimes you may miss the to interpret correctly. So these are all the issues. How we are going to solve this. This is my last portion of my talk. Next slide, please. Okay. Quality control. This needs to be done day to day for reliability and reproducibility. And this is of two types of control. One is material and equipment. Material includes medium, antibiotic disc, or antibiotic concentration in the panels of the automated system, and the incubator. So you have to make sure that medium is good, antibiotic discs are good, and the incubator are calibrated. So this is about the material and equipment. It's not we have to make sure that it works. The second component is very important, that is control procedures. This is the human error. So the human should have a good technique and understanding and skill to prepare the inoculum and inoculating organism onto the plate, simply called as inoculation. Inoculum preparation and inoculation are human skill. Again, incubation time, you need to be a little careful. It's not automated. It's a human error. It will be. And reading or interpreting the result. These are all the human things. Next slide. Okay. So how often you need to test the antibiotics or part of the routine panel? QC training, it's preferable to do daily. And especially daily is important because we don't know every time the disk batch may differ. So that is the reason. If there is no disk batch difference on the day, then you can skip that day. But still, you need to do 4 times a week minimum. So 3 days in a week you can skip, provided you are not bringing in new batch of disk into the day. And control tests should be read and evaluated before reporting the result. So first, all the controls has to be passed, verified, validated, and then only you can start taking the patient results. Then you have to document your results after releasing the results, you can plot into the Lenny-Jenny chart and do the analysis. So how you need to do is examine the results of last 20 consecutive tests. I'm saying not days, consecutive test. If you are doing daily, then 20 daily dates, or 4 times a week means consecutive test it is. So zones falling consistently above or below the target, you should be careful. Though in the next slide, I will explain you. Next slide. So here you can see that the zone diameter inhibition, if suppose between 16 to 22 is the QC range, ideally it should be 19, but it's acceptable to be between 16 and 22. Upper limit is 22 and lower limit is 16. If there is one away from the lower limit or consistently on the lower limit, it's not good. Or two consecutive ones on the lower limit. It can be any one of the three. Will tell you that something going wrong. So you need to repeat the test. Make sure that all the dots occurs within the specified upper and lower limit. This is the one, and single result out of the range in the upper limit is also very important. So these are all the QC over the period which you need to monitor and see that whatever the disk you are having continue to retain the potency and it's not falling. Not only the disk, even the medium. Okay, next slide. Okay. So how to handle the QC result of the range? Two consecutive zone diameters of 20 straight outside the range or multiple disk more than 2 are out range of 1 day. So this is what I've explained earlier. The important point in the slide is the second point. Resistance in resistant control strain not recognized. So majority of the people, they focus only on the using the susceptible strain and susceptible result. It's very important. Every day you have to use resistant control and make sure that the resistant control strain also shows it as a resistant. I will give you some examples in the subsequent slides. So it's not only the Lenny chart, even the resistant and resistant control strain has to be recognized. The second point is important. Next. Next slide, please. Okay. So I think that slide comes one slide later. Many times your troubleshooting can be solved using the QC strains. So for aminoglycoside, definitely you will be using Pseudomonas aeruginosa ATCC 27853. So if there is something wrong in that, you can interpret that as a divalent cation is the problem in the medium. If tigecycline is problem with the QC strain, then you can understand that the media is an old prepared media, that cation adjusted Muller-Intenn broth, which gives an IMIC. If the erythromycin for staph aureus, it's not falling within the QC, then you can suspect low pH of the media, which results in too small zone size. That is, it will show as a resistant. Then E. fecalis against trimethoprim sulfamethoxazole, if the QC ranges are not proper, that will tell the media has got more of thymine and thymidine, which gives a produce zone size below the quality control limit. So these are all the antibiotic and QC strain helps to resolve or to identify the problem with the medium, the agar. Next slide. Okay. So these are all the quality strains you need to use. Here you can see whatever I have given in the, I have given as a 2 boxes. Upper box, generally we use E. coli 25922, Pseudomonas 27853 we use, and Staph aureus 29213 we use. These are all the 3 common ones which you use. You need to understand that Staph aureus ATCC 29213 is a weak beta-lactamase producer. So it will produce penicillin and it will be resistant. So if you are looking penicillin susceptibility for Staph aureus, not oxacillin, then you need to have a different control strains. And these are all, rest are all wild type. And the pneumonia, Streptococcus pneumoniae, ATCC 49619, it will have a reduced susceptibility to benzyl penicillin. So it is not in a wild strain. Haemophilus influenza susceptible but wild strain. In Haemophilus influenza, there are many number of control strains are there where reduced susceptibility, high resistance are there. So appropriately, you have to pick up and use wherever it mandates. And as I mentioned to you earlier in a couple of slides earlier, QC strains for resistant is very important. Generally, we use E. coli ATCC 25922 for susceptibility. We generally don't use the resistant isolate. If you are interested in picking up the resistant, it's suggested to use resistant ACCC strain. That is 35218, which is expresses TEM1. Similarly, Klebsiella pneumoniae, ATCC 700603, which we use to pick up ESBLs, this will have SHV 18. And for Klebsiella pneumoniae, 2814 produces KPC3. Staph aureus 29213, it's a beta-lactamase producer. So you need to be a little careful for what intention, what to use. So you need to dwell little more on this. If you are doing on AST any particular other than routine test, make sure that appropriate QC strains are incorporated. If you want any doubts or clarification or even control strain, we will be happy to help you to share the control strain from us. If we don't have, at least we know where to get it from. So we can facilitate you from where to obtain. In many centers, it is given free of cost. In certain places, for payment, you need to get. So we can guide you in this regard. Next slide. So here I've used, this is the last portion. I've used two words. One is verification. Another one is validation. This is exclusively for commercial automated system. What is verification is FDA has approved. You want to just verify whether that works in your place or not. It's a one-time process. Verification is a one-time process. Whatever the FDA has told or CLSI have suggested, you are just counter-checking. Verification is counter-checking. Validation in other way, the FDA has not said or CLSI has not said, but you want to, in your system, you are validating that. For example, what I would like to say is, FDA has given breakpoints for tigecycline, but the CLSI has not suggested any breakpoint. So you can validate within your system for tigecycline. So how to do that is what I'm going to explain in the subsequent slides. Before doing that, these are all can be done only in the automated system. So before that, routine testing, quality control of automated system, I will go through in this slide. So for the commercial system, once in a month, make sure that the temperature control components are intact, optics are intact, movements of the machine parts are intact. This needs to be checked every month and calibrate for this. And whenever you are using the panel, antibiotic panel card, just straight away from the fridge, it should not go to the inoculation and into the machine. You have to thaw it for some time. Leave it in the room temperature for 15-20 minutes or even minimum half an hour. Otherwise, if without leaving it at the room temperature, if you take it straightly, you are tend to get error reports. And the buffer used should have 0.045% NaCl. That is important. Don't substitute other than manufacturer supplied buffer. So it's very important. Buffer 0.045% is important. Then density check. Again, McFarland's, if you are good enough and you have procured the McFarland from the calibrated authorized center, it's fine. If you are manually prepared and if you are not quality checked, then it's not to use here. And every time you have to check for the new products in the automated machine, every new batch of reagents has to be checked. And because now you are not sure how the new reagents have been shipped, because these are all not prepared or manufactured in India. It comes from either from North America or from Europe. So it's very important. to check the new batch. And the important one is known susceptible, known resistant internal controls needs to be included. Not only susceptible, even resistant needs to be included. And every antibiotic has to be validated. In the panel, don't take it for granted that all antibiotics are working. 90% it may work, 1 or 2 it may not work. So you need to be careful. Next slide. Okay. So now this is the most latest information from the CDC and the FDA. So both CDC and the FDA jointly, they are given a breakpoint implementation toolkit. They have come out with this document and YouTube presentations. If you have a time, you just go to the YouTube presentation and see this breakpoint implementation toolkit. Here, whatever I said earlier, the one-time process of verification for the device manufacturer for ASD by the FDA breakpoints can be obtained, whereas validation, which is an ongoing process, using breakpoint that are different from FDA. Because FDA has given breakpoint, but you are following UCAST. Then you have to validate that. And this is an ongoing process. This is what I'm trying to tell you now. Next slide, please. 1 second. Sorry. So here, as I mentioned to you, verification, if the FDA has cleared, then you have to just counter check once. That can be done with 10 to 15 isolates per antibiotic. Just run it through, and if it gives the expected results, that's fine. That's all. Verification is counter checking. So this can be for the antibiotic panel, this can be for software, and this can be for the medical device. And this has to be included for this verification or counter checking. 10 to 15 isolates per antibiotic you can use, and you can document, and then you can trust the machine, trust the panel, trust the software interpretation, you can go ahead. So verification is simple. Validation comes when the FDA gives the interpretation, whether that breakpoint interpretation is you're not using, but you are to follow the UCAST, then you need to validate. So how do you validate? For the panel, for the device, and the interpretation is what now I am going to tell you. It is almost similar. It's not very difficult. Instead of using 10 to 15 isolates, the CLSI recommends to use 30 isolates. So the probability should not be less. That's all. So that's the reason they are saying to use 30. Now I will go next slide, please. Okay. What is this toolkit contains? So both the FDA and CDC together, they have developed an antimicrobial resistant bank, which gives you breakpoint implementation toolkit. So there are 4 toolkits are there. Toolkit 1, 2, 3, 4. The toolkit 1, it's known as BIT. Toolkit 2 is known as PTA. 3, it is known as PFA. And 4, it is known as ACI. So for enterobacterials, this gives you, for the entire enterobacterials, carbapenem, cephalosporin, fluoroquinolones are validated using this toolkit. And there are another toolkit for enterobacterials. This kit validates for aminoglycoside, colistin, and piptazole. So for enterobacterials, you need to have 2 different kits, because we are not using, if you are wanting to use not FDA, you want to use CLSI or UCAST, then you have to use this toolkits. For Pseudomonas aeruginosa, it checks for aminoglycosides, carbapenems, cephalosporins, colistin, fluoroquinolones, and piptazole. Only single kit is there. For Acinetobacter baumannii complex, carbapenems and colistin are very validated. So only 2 drugs, and this is another kit. So to obtain this kit, you can write to this CDC website, and it's called AR Isolate Bank. I think they at present for US citizens, they are giving free of cost. I'm not sure about outside America, whether they are giving free of cost or only the processing charges you may need to pay along with the shipment charges. So this will be more authenticated. because majority of us we are using not the FDA, CLSI and UCAST. Very few are UCAST. Even for CLSI, we may not require this. Those people who are using UCAST in India, it's better to have this kit and follow. Next slide, please. Okay. If you are bringing new antibiotic to a new system, then what you need to do is drug-bug combination. In one set, you have to use the sensititer MIC panel manually. And in the machine, also you have to test parallelly in the machine and manually. And how do you do? You need to do for 5 days and 5 isolates for accuracy, 2 isolates for precision. These 5 isolates can be tested only once, means only one sample. Whereas in precision, you have to use it in triplicate. That's important. And for these two clinical isolates for accuracy and precision, you need to include QC strains. Pseudomonas aeruginosa, this particular control strains, all QC strains has to be done in triplicates. So for accuracy and precision, between both sensititer and the automated machine, you need to follow the schedule. The more work will be there on the first day and the second day. Third day, it's only for the precision. Fourth and fifth day, reproducibility for the QC strain alone, it's there. So this is the scheme they are recommending for commercial automated systems. For the new drug brought in, recently they have brought ceftazidime avibactam into the commercial system. So you need to validate using this one. So why I have deliberately included in my talk this one is when you are having an NABL accreditation, there are chances that they may ask you whether you have validated in the new panel using this scheme. So it's very important to do and document and maintain the record for NABL accreditation. Next slide, please. Okay. So the FDA and UCAST by and large the set of rules are derived from ISO 20776. So which was drafted in 2007. So it's almost the same for UCAST and FDA. And even the criteria are almost same. The only difference is very major error. The ISO recommends less than 3, whereas the FDA brings it little more strict and places it 1.5. It should be less than 1.5. And for instruments, no comments are available for growth failure, or for FDA doesn't tells nothing much about the reproducibility. Otherwise, it's by and large the same. Next slide, please. So final slide, just before ending, I would like to recall, encourage people to enroll in the external quality assurance scheme provided by Dr. Chandwatal from Gangaram Hospital and from CMC Vellore. It's very important before the external quality assurance scheme you participate, make sure that you, apart from daily routine QC, once in a while, it's important to check the internal quality assurance. So some people they can blind the the bug, and they can give you, they can choose whatever they want to challenge with, and internally you need to have exam for it. That is internal quality check. And then you apply as well for the external quality. So it's more important. Apart from daily QC, internal quality control is in place and external quality control is in place. And in the external quality, what we do is we give the regular feedback regularly, and that is published as lesson learned from that particular episode of EQUAS. And this helps to facilitate standardized approach in every center. Next slide. Okay, briefly, can you press next, ma'am? So this is the QC, where the ID, sterility check, inoculum, quality control, interpretation of the results, validation of the result constitutes quality control for AST. And with the results dispatched and interpretation, external quality assessment scheme comes. What is internal quality control is? Can you press again, ma'am? Internal quality control is something similar to external quality. The only difference between internal quality and external quality is somebody unknown challenges you. Internal quality, somebody known within the lab challenges you. That's all the difference between the internal quality and the external quality. And the QC plus IQC plus EQAS is the quality assurance. And from Vellore, we provide, next slide. From Vellore, apart from tier 1, we have two systems, tier 1, tier 2, tier 3. Tier 3 is simulated specimens. So there are a lot of takers for tier 1. Almost everyone takes tier 1, where we provide smear, culture, and routine serology. Whereas in the tier 2, only optional people are taking molecular panel for ID of bacterial pathogens available for meningitis panel and respiratory panel, because the fastidious organisms are there in the scheme 1. Whereas in the scheme 2, mostly gastrointestinal bacterial panel, non-fastidious organisms are there. And in the scheme 3, it's more of a specialized external quality assessment, something for virulence and AMR. Few examples for virulence. You can go through the website for a long list of molecular detection of virulence and AMR. For staph aureus, PVL, AMR, ESBL, AMP, CCRO genes, some PB3, something like that. For scheme 4, culture-based detection of AMR, like population analysis profile for hetero-resistant visa or hetero-resistant, these are all covered in the scheme 4. And in the scheme 2, in the gastro panel, we do have for Campylobacter, Helicobacter, and some fastidious organism. For scheme 1 looks anthrax. So you can go through the website, and whatever you require or help or you want to counter check, please approach us. Thank you very much. So I'll be happy to take any questions if
Thank
there
you
are
so
any.
much, sir, for an excellent presentation. If Dr. Bharati ma'am has joined, I will ask her to please give her remarks. And if there are any questions, please put it in the chat box. I think ma'am is there, but I didn't see her. Anyways, sir, I have one or two questions.
Sure, please.
One is, you talked about the variations in the glass plate. Do we have variations? Because most of us now use disposable plastic plates. Do you think there's going to be a variation in that also?
May not be there, because polycarbonate plates they are using. So there may not be a problem with the plates. Plastic plates.
Plastic plates. Okay. And another thing is that I would like you to tell the house about 0.5 McFarland response. It's one of my favorite questions I ask in bench. But I want the house to know, the students particularly, they usually fumble up here.
So McFarland 0.5, it should, the approximate number of colony forming unit it contains is 10 to the power of 8. And there is a protocol how to prepare in-house, and you can use in-house prepared McFarland match. I think 0.5, 1 McFarland is good enough. There are series of 0.5, 1, 2, 4, everything is available. For any microbiology lab, 0.5 is good enough. There is no need for a 1 also, because 1 is required for chocolate agar plate for Streptococcus pneumoniae. You will be using blood agar, so 0.5, 1 is enough. 0.5 and 1 is beyond that, nothing is required. So 0.5, 1 alone is more than sufficient. And make sure that every 6 months in-house prepared McFarlands are thrown out. Don't continue to retain that one. And what I will do is, if you want to know the procedure to make McFarland tube in-house, we can share the procedure how to prepare. What chemical, how to reconstitute that, and how to quality control the McFarland's tube. So it's much easier. No, there is no need for you to every time go and buy that one. In a resource poor settings, I encourage people to, I will share the protocol. You can prepare on your own. And definitely, if it is going to be automated machine, then for precise, they will give you. So when you buy a 20 lakh machine, they will give you the free of cost that density check. density check. So even a resource per setting also, it's a one-time investment. It doesn't cost more than 4,000-5,000. You can buy and have it. So that if you don't have an high skilled people, there is attrition in the lab. It's better to have a density check.
Yes. Okay, sir. I remember when we were postgraduates, my guide, Dr. Krishna Prakash, it was his favorite exercise. The moment you were posted in AST, it was your job to
But the
make
McFarland.
McFarland, match it with the Vekaram card every day and tell it to him whether it matches with it. And the technician would, grill us. It is not matching. It is not matching. That time we never had commercial. I think now it's a more entitled generation.
So in this lecture, I have covered basics a little bit because most of you, all postgraduates, they would have taught the basics. So I kept it short, more on the automated system. I've covered. Another area where we need to have little more exposure is phenotypic versus genotypic susceptibility testing. So I don't want to add up more slide and take much of the time. So you cannot catch up with that kind of information. So I thought we can divide into 2 sessions. Today, I emphasized more on the automated system. Next time, we will be more happy to share information regarding phenotypic versus genotypic. And we would like to give the update of CLSI and UCAST and with the rationale why they are changing the breakpoints.
That I'll try and schedule in
April, May we can do.
Automation was very good because most of the time we find that the students and even us, if something is running in the automated and something we cross check with the disk diffusion, many a times we find there is some
discrepancies there,
and suddenly you realize it is your disk diffusion which is giving you a correct result, but the automated one is not.
Sorry, ma'am, to interpret. One important point, I don't know whether I have made it very clear to all the students. Many people, they believe that automated system results are ultimate. So your manual method will be wrong. No, never. Don't assume that machine is good and we are wrong. So the chances for error with automation is slightly higher. So 90%. In human error, we cannot say whether it is a 10% or 90% because we don't know the skill of the individual. So if the person has not been trained, he may have only 10% skill. He may not have that. So it's very difficult to quantitate the skill of any human, whereas automated we can do. And the percentage given for automation is 90%, but not 100%. So chances are there 1 in 10 will give wrong result. So it's very important. Don't assume that machine is 100% correct.
Right.
Since we don't have gold standard, human error are very high and it varies from center to center. We cannot absolutely match and say.
Correct, sir. I think Dr. Bharti ma'am has joined, so I'll request the Honorable President to please.
Yeah, I joined late, but I've heard most of it. So I could not welcome Dr. Balaji. I was just busy with some personal preparation of my father-in-laws. So it was a great talk, and I think very, very important for the PGs to listen. And who else, none else than Dr. Balaji explaining in such great details. And that was really nice. So thank you so much, and very well explained. So sorry for joining late, but thanks a lot for the great talk, Dr. Balaji. It was really good, and we look forward to the second series
Yes.
as you've promised.
Sure.
We look forward to that.
Once the CLSI and UCAS comes out with their 2024 update, we will do that.
Great.
Sure.
That will be great. I think it's a very great initiative, Sonal, which you have taken, and sitting in the home's comfort, you can learn from the experts.
Yes.
Nothing else could have been better than this. Because in the conference, you're just busy juggling between the various sessions. So this is just perfect. So thank you so much, Dr. Balaji.
Thank you.
Thank you, Sonal, for the great initiative.
Thank you, Dr. Bharati.
Thank you.
Bye-bye.
Okay. Thank you.
Thank you, ma'am. Thank you, sir. Thank you, everybody, for joining.